You know what? I gotta hit the go live button. Jeez. All right, here we go. All right, there we go. We should now be live. Welcome everybody to our Akka.net community stand-up for June. So this is my first time using my little OBS setup that I normally use for doing my Twitch streams I just started doing over the past couple months. But today we're going to go ahead and use it to do a little bit of YouTube. So first thing I kind of wanted to get into as part of our community stand-up is the work that's going on with Akka.net 1.421, which is in beta right now. So let me go ahead and pull this up. So we released this Akka.net 1.421 beta package out to NuGet on June 3rd, so just a little bit less than a week ago. And this is a fairly significant package for a minor release. The big changes that we've introduced so far are mostly performance improvements, but also we made a pretty significant set of design changes to the Akka.dependency dependency injection NuGet package. So some of the major fixes I kind of wanted to talk a bit about mostly affect people who are using Akka.remote. So for instance, if I go ahead and take a look at some of these changes here, for instance, go ahead and grab both of those. So long story short, one of the things we put a lot of effort into for this particular release was trying to take some of the historical sort of, let's say, methods we've been using in Akka.net for 7-8 years for things like parsing actor paths, which we had to do on almost every single remote message we deserialize. Trying to go ahead and take those and find a more efficient way to parse them by using the new span constructs that were introduced in .NET Core 2.0. And we were pretty successful in doing that. We were able to go ahead and remove URI.tryParse and replace it with a method that is roughly 3 times faster and allocates half as much memory. We're also able to do things like eliminate, lazy string allocations from the address object. We're just using a string now rather than having this whole lazy construct here. This will actually reduce the entire memory footprint of Akka.net if you use it. So that's another big benefit we kind of added to the program here. We were able to make the ask operation about 10% faster. We don't need string builders anymore to go ahead and generate the base64 encoded random actor names that we generate there. Gregorius made murmur hash 33% faster and now allocates 0 memory. We use this very heavily inside Akka.distributed data. We use it for consistent hash routers. We also use it in the cluster sharding system pretty heavily. So that is now an allocation-free method. We were able to remove an actor path to string every single time we had to resolve a local actor reference. That's another set of allocations we got rid of. But probably the most important performance change we made was actually reversing something we introduced in Akka.net 1.419, which is in 1.419, we were working on trying to change possibly the default dispatching system. We went ahead and we introduced this call, threadpool.setMinThread00. What this does is it basically removes the minimum thread count from the .NET thread pool for your Akka.net process. Now, the reason why we did this is in our benchmarks, both in our distributed benchmarks that we ran inside an Akka.net cluster that runs in Docker and so forth, but also inside our sort of remote ping pong benchmark, which I'm going to show you down here. This significantly increased the throughput numbers that we saw in there. However, we got some input from at least 3 users who are running Akka.net in fairly high traffic systems that reported disastrous results from calling this. Long story short, because the thread pool no longer has a baseline minimum number of threads in it when we do this, this actually means that the thread pool has to dynamically scale up and down all the time, and there's some pauses that get introduced when we do that. So I had made the judgment call that I thought this was a risk worth taking. But after collecting some data from those users, I decided that it's probably safer for us to get rid of it. You can still go ahead and make this call yourself when you go and start up your actor system if you don't think it'll have any adverse effects on your application. But we're no longer going to go ahead and do this for you. We're just going to let Akka.net use whatever the thread pool minimums are. Typically, the thread pool minimum is going to be 1 worker thread per core and usually 1 maybe one or, well, not necessarily one or fewer I/O threads per core. That's typically what this defaults to, although it depends a lot on your version of .NET, your processor architecture, and a couple of other factors. Now, so getting rid of this should have had an adverse effect on Akka.Remote's performance, and it probably did. We'd probably be going even faster without that. But because of the other performance improvements that we made, Akka.Remote is still faster on net, even without that change, than it was before. So these are the remote ping pong numbers that were being run on my development machine here. I basically ran both of these benchmarks relatively shortly after the other on a machine that had all the instances of Visual Studio and Chrome and all that closed. We went ahead and were able to observe an end-to-end throughput at just doing, let's say, a single actor. So this is one actor on either side of a remote connection doing a back and forth. They were able to process about 110,000 messages per second on the old version of Akka.NET. And then when we got up to, let's say, doing 5, 10, 15, 20, 25, we were doing somewhere in the ballpark of about, let's say, 182,000 messages per second on average is probably what that would average out to. Maybe 183,000 messages per second. Well, if we take a look at where we are after this, we're doing in the ballpark of about 190,000 messages per second everywhere. And that's without having the thread pool set min thread setting enabled. So if you really want to go ahead and try to drive up Akka.NET throughput, you can still enable this in your own applications. However, there's probably some diminishing returns once you're under a high enough load. That's what our end users saw. But still, Akka.Remote is significantly faster in this release than it was in the previous one. On top of that, the memory footprint's smaller. Operations we're not using in this benchmark, like ask, are significantly faster. So these are all some nice improvements that are available. Now, this is still in beta because we also made some pretty major changes to Akka.Dependency injection. The biggest thing we did is we renamed some of the classes. Now, we didn't break any of the old classes. They're still there. So the service provider setup and the service provider actor system extension are still there. However, we introduced new versions of those classes, namely the dependency resolver setup and the dependency resolver. This was done in order to avoid name collisions with the older version of, well, in order to avoid name collisions with the Microsoft.extensions.di classes that share these names. One reason why we did that. The other reason why we did that was to allow us to take this new dependency, this iDependency resolver type right here, which is basically an abstraction over some of these. And this is designed to make it so when people are doing unit testing and dependency injection and so forth, we can go ahead and abstract away the Microsoft.extensions. Dependency injection service provider and just go ahead and use, let's say, a simple, service interface you go ahead and define yourself to serve up these dependencies. That's one of the reasons why we have this there. And then on top of that, we also have some non-generic props methods for dynamically spawning actors via DI. That way you don't necessarily have to use one of the generically typed methods to do this. A couple of other important changes and fixes. We made some fixes to the Akka streams file subscriber. We also fixed a pretty massive memory leak with Akka.distributed data. Long story short, for using OR sets and G sets, both are both of those set implementations could never get their digest to match. So whenever we were sort of replicating changes from those, the gossip would never stop, and it would gradually go ahead and eat up quite a bit of memory. We have since fixed that. In fact, Gregorius, that's fixed for OR set and G set, right? Okay, we should go ahead and submit another pull request to do G set things. It's got the exact same sort of structural issue. So yeah, let's go ahead and do that before we do the final 1.421 release. OR set's much more commonly used, though. In fact, I think the reason why this showed up is I think OR set, if I'm not mistaken, can get used in cluster sharding, I think. Now down here, the last bit of changes we made is some of the performance improvements we made in Akka.NET 1.4.2.0 involved basically optimizing vector clocks, which is how we version state in Akka.Cluster. Version vector, which is how we version the sort of object lifetimes in distributed data, uses a very similar data structure. So we're able to port a whole bunch of those performance improvements to that system as well. As a result of that, we now have a much more memory efficient implementation of distributed data as well. I also just realized, Gregorius, I'm not sharing my screen with you on Google Chat here. So let me go ahead and put that on. All right, there we go. That should work. All right, perfect. So that's what's going on with Akka.NET 1.421. Now, we have a couple of other things we're working on before we get this out of beta. We have had some users report a couple of issues with the beta so far, namely that the dependency injection signatures changed in a way that it makes it, essentially we're returning an object instead of a strong type when we're using the iDependency resolver. That's something that needs to be fixed. So that should be a relatively easy API change that we'll make. So that's one thing we're going to do. And then we're in the process right now of also trying to troubleshoot an issue that got reported with using fully qualified domain names inside Akka.NET with the new Akka.actor path parsing changes. However, it looks like that issue isn't actually related to what we did in 1.421. So we're looking at resolving all those issues, and we have a number, if I go here, we have a number of other issues in the Akka.NET 1.421 milestone that we're still working on. Some of these are issues that we kind of just keep carrying over and over again. So we have a couple of these issues that are still hanging around. But the big ones have largely been completed. We're working on a couple of others. I don't know why this didn't get merged. Yeah. Oh, because I got to update the branch. All right, well, I'm not going to do that. Since that's just changing a log message. All right, there we go. Okay, that looks good. So we got a couple of other issues that we're still working on fixing for Akka.NET 1.421. Our hope is to have a version of this out by the end of the week. Primarily to get those distributed data fixes out to people. Some ongoing performance work that is still being done at the moment for a future release of Akka.NET. We are working on a couple of other issues here. I'll go ahead and pull these up. Let me get rid of those. This is an issue I'm working on at the moment that's not quite functioning, which is optimizing the child container. This is something that we're looking at for actors that have a large number of children. So let's say it is not uncommon for some applications to have parent actors that might have, let's say, hundreds of thousands of children actors underneath them. That data structure is immutable right now, which means we have to do a full copy of it each and every time. Well, we've gone ahead and we've experimented with changing that data structure from an immutable one, which is what we have here, to a mutable one down below. And what we've seen is a pretty significant drop in the time it takes to create an actor and a lot less memory being allocated in order to do that. So that's as a result of essentially just changing that data structure around. Now, we're not quite done getting that, getting this sort of, let's say, fully tested here. As you can see, we've got a number of test failures. It turns out there's some cases where we still really need to have an immutable data structure there. And the reasons for that basically amount to multiple children all being able to be spawned at the same time on different threads. That happens inside actors like the top level user actor and inside a couple of places inside Akka streams. So we're working on trying to clean some of that up and see if we can make that work. That's one performance optimization we're looking at. The next one we're looking at here is actually trying to go ahead and apply some spanification to the way we serialize actor paths. This is another, so if you look at the Akka.remote, let's say serialization pipeline, you have deserialization, which is what we improved in this release. And then you have serialization, which is something that we haven't really touched yet. This is basically trying to help reduce the amount of, let's say, allocations that have to occur in order for us to fully serialize an actor's path. And so we're still in the process of working on this. I don't know what my last numbers were. Let me take a look at this. Let's see. Yeah, as I point out here, the code that I've written so far is pretty ugly. So the actor path.toString method in the latest version takes about 183 nanoseconds and uses 112 bytes of memory. And whereas what we started with was about 205 nanoseconds and 168 bytes of memory. So, and by the way, that's including all the other performance fixes that are already bundled into Akka.NET 1.421. So this is the baseline for this is actually starting a lot further back than where it is right now at Akka.NET 1.420. This number would actually be quite a bit higher down there. So these are some of the things that we're also looking at for performance. I think I may have found earlier when Gregorius and I were investigating a bug, a way to go ahead and reduce allocations and performance even further inside the remoting pipeline. So that's something else we're going to be taking a little look at. Let's see, Gregorius, do you have anything to add so far? All right. Okay, no problem. Let's see, Akka.Persistence.link to DB. I know Andrew, who's not on the call here today, has a new release for this coming up. I've asked him to prepare some release notes for this. This is meant to be kind of our high-performance replacement for Akka.Persistence.SQL.common. So that's something that should be coming out in the next week or two. So stay tuned for an announcement around that. One of the other things that we're actively working on, we've got a couple of other little initiatives in the hopper here. As of last week, we've just started laying the groundwork for Akka.Management. This project's going to contain a bunch of nice little features for Akka.Cluster users in particular. What it's going to contain is basically a set of APIs for being able to go ahead and use a little REST API, basically over HTTP, for invoking some methods on your cluster, for being able to go ahead and do things like have nodes join, have nodes leave. You can kind of think of this as like a HTTP analog for a lot of what Petabridge.command does, for instance. That's something that Ishmael on our team has been working on. So he submitted a one PR for that. We also have an internal prototype of Akka.HTTP that is being used by this Akka.Management implementation. Now, that's not something we've had on our roadmap yet, but it's one of the major feature areas that Akka.net does not yet have compared to the original, let's say, Akka project itself, is that we don't actually have support for Akka.HTTP at the moment. That's something that we're probably going to go ahead and merge in and keep as an internal module for the time being. This whole thing, Akka.HTTP, is built on top of Kestrel under the covers. So we aren't going to have all the same, let's say, bells and whistles that Akka.HTTP itself has. That's an entire HTTP library built from the bottom up using Akka streams everywhere. There's a lot of things we would need to do to get Akka streams up to snuff to be able to go ahead and handle that, which is something we do want to do, particularly in order to support Artery and a lot of the other work we're doing in Akka.net 1.5. But that's just kind of out of scope for what we're kind of focused on in the short run. So this is something that we're going to merge in. The other thing that we're working on right now are to help improve, let's say, resiliency during split brain scenarios inside an Akka.net cluster. We're in the process of working on some lease implementations, which is basically a way to go ahead and create a distributed lock. And so one of the new split brain resolvers we introduced, I think in Akka.net 1.417, allows you to go ahead and set up allows you to go ahead and basically set up an Akka.coordination.lease object as your way of resolving who's on the right side of the split brain or not. And so every node who can acquire that lock gets to stay in the cluster. Any node that can't acquire that lock has to leave. So that's something that we're in the process of currently working on in order to try to make it a little bit more, basically make it so in order for us to go ahead and validate who's still inside the cluster, we need to validate which processes are actually running, which requires those nodes to be able to go ahead and potentially talk to someone else who's not in the cluster. In that case, we're going to look at using Azure Blob Storage for that. We're also going to look at doing an Amazon S3 implementation of this using S3 object locks, which are basically the same idea as Azure Storage Blob Lease. So actually, this should say Azure Storage, not Akka Storage. That's something else that's kind of being worked on behind the scenes. I'm not sure necessarily what the timeframes are for releasing any of that. We're kind of doing it here at Petabridge. We're working on some of the lease implementations to support some of our active customers that are deploying large Akka.net applications in cloud environments. So that's kind of what that's being done for right now. So we're kind of doing this on a little bit of a piecemeal basis, but all that work will be made available under Apache 2 and releases official NuGet packages through the Akka.net project. So that's what's going on with all that. Now I'm going to drop a link, by the way, to the discussion page here in the chat in case anyone wants to participate and ask some questions on our discussion thread afterwards. Now, a couple of community updates, so things that don't necessarily pertain strictly to the Akka.net source code. One I wanted to share was this case study we published in May on the Petabridge site. This is from an Akka.NET user called Vertech. They're a company that does IoT, and they're based in North America. This case study was written by, let's see, John Walensky, who's a solutions architect there. And what they're using Akka.NET for in this case study is they're using Akka.NET to go ahead and simulate all the conveyor belts and so forth you need to go ahead and build baggage handling systems at large airports. And so he wrote a really great and beautiful case study here talking about how they're able to use Akka.NET to go ahead and simulate all these complex devices, because it's really inconvenient for programmers on his team to go ahead and have to get in a car and drive over to a facility where they actually have all this hardware lying around. So if you're working in IoT and you're interested in taking a look at Akka.NET, this might be a really good entry-level use case where you can use Akka.NET to go ahead and simulate basically some of these SCADA inputs and everything else that are being used for large-scale industrial systems. So they wrote a really great case study for that. So that's one thing I wanted to share. Next thing I wanted to go ahead and mention real briefly is that if I go ahead and open up, actually, I'll just do this in the browser. Petterbridge.com/cluster. This has been around for a couple of years. This is our end-to-end Akka.NET distributed programming with Akka.Cluster, Kubernetes, and Docker course. This is a little bit out of date at the moment. A number of things have changed since we originally wrote this in 2019. There's been a lot of advances in Akka.NET itself. Akka.NET 1.4 has come out since then, for instance. And then there's also been a lot of development around some of the best practices for trying to run Akka.NET in environments like this. So we're in the process right now of trying to update this entire course and get it ready for republication. And we're going to try to go ahead and promote this a little bit more thoroughly when it comes out. Now, all the information is still good in here. It's just that some of the code samples and some of the practices we recommend are a little out of date. I've done a fair amount of work in modernizing the sort of end result of this already, but I've got to go through and finish updating all the individual lessons. We hope to have this done by the end of June, and this course will be free. It'll be kind of similar to Akka.NET Bootcamp, where it's like a learn by doing course. So you'll go ahead and clone a repository and kind of do some kinesthetic exercises in order to learn how to work with Kubernetes, how to work with Akka.Cluster inside of it, and so forth. So this is something that we're in the process of actively working on, and I hope by the time we do our July meeting, I'll be able to go ahead and show you the finished product. That's part of my goal for this. So that's something that we're actively working on right now in order to try to help lower the learning curve for Akka.Cluster developers. And the last thing I wanted to mention, as far as our community update goes, is a little project I've been embarking on as part of my Twitch stream, which is this DrawTogether.net application, which I'm going to go ahead and take an opportunity to demo in this meeting here. So back in, I guess it would have been February or maybe early March, one of the things I kind of polled the greater .NET community / Akka.NET community about was a number of different basically live, like learn by doing sort of scenarios I could do on a live stream that people would be interested in. And the number one thing people wanted to see was they wanted to see me build a collaborative drawing program that uses Akka.NET to go ahead and synchronize multiple readers and writers at the same time. And so over the course of about 6 hours, starting last Tuesday, I've gone ahead and I've streamed about 2 hours a night. Maybe actually, I think I did about 3 last night on my Twitch channel. We were able to go ahead and actually get a collaborative drawing program in Blazor up and running. So I wanted to demo this real fast. And all the source code for this is totally public, so anyone can download it and run it as much as they want. I think I licensed everything under Apache 2. So you should be able to go ahead and enjoy all this code with the exact same license that Akka.NET uses. So let me pull this up real fast. All right. Okay, there we go. So if I go ahead and I click on Paint in my little Draw Together application, I'm going to go ahead and click on this Launch New Session button. And this is going to go ahead and create a little, let's say, SignalR powered Blazor drawing UI where I can go ahead and draw little brush strokes like this. I can change the color around if I want to. So I made this kind of a little orange color here. I could increase the cursor size. So I can go ahead and do that, et cetera, et cetera. All right, that's looking pretty good. Now, what's really cool though, in terms of why I think this demo is so much fun, is I'm going to go ahead and open up a new anonymous tab here. Move that over. Well, actually, I guess technically I don't need one, but I'm going to do it anyway because we're actually not using cookies or anything like that in this sample. But if I go and pull up this same little window here, you'll notice that this user just got synchronized on everything that was drawn in this person's channel. And if I go and I draw a new brush stroke, that's going to appear on both monitors at the exact same time. So I can go ahead and draw a little X here. I can go ahead and on this screen, let me go ahead and do, I don't know what type of, I guess that's also orange. Okay. Try that. Adds more green. Okay, perfect. And I'll go ahead and do 14. Now I can go ahead and draw over this screen as well. So we're basically using Akka.net to go ahead and synchronize the state of what this particular shape looks like for all the concurrent users. Now, if I go ahead and I close, let me go ahead and close that. And I'll go ahead and close this and this UI as well. Now, hopefully my application doesn't shut down. Looks like it didn't. Perfect. If I go ahead and paste this back in, I can go ahead and reacquire all that state that was previously there because it's all being held in memory by an Akka.net actor behind the scenes. And in fact, if I go and take a look at my, if I go to my little paint instance actor, and I'm going to set a little breakpoint down here. This is the method Blazor is invoking to go ahead and add some more draw strokes here. If I go ahead and I add a little shape, you'll see that we have 534 strokes, and these are just these little objects that describe the color and the Cartesian plane position and the cursor size, which is the radius of the brush stroke. We just go ahead and we add those strokes together like that. Now I've got to go ahead and let this continue because I'm basically every time I hold the mouse down and do this, I'm actually invoking that method potentially thousands of times on the server. So this is what we've got so far. And if I go back here, I can always go ahead and open a brand new session like this. Go ahead and do a little bit of pink or maybe salmon color. I guess it's kind of gray actually. I can always go ahead and basically open up a brand new drawing shape like this. And many users can concurrently all go ahead and join all these different little drawing sessions. So I've got a little bit more work to do on my Twitch stream to kind of get this sample the way I want it. Right now, we're not using Akka.Cluster or anything at all like that behind the scenes. This is all being done just strictly with a local actor system right now. That's one of the things that I'm going to be working on over the next couple of weeks is basically building a SignalR backplane and building, by the way, I just dropped a link to this in chat, and building a little bit more functionality into my little sample application here. Now, I don't have a link to my Twitch stream in here, but I can go ahead and you can go ahead and grab that off my Twitter profile or anything else. Actually, I'll just go ahead and type it in chat here. But it's twitch.tv/Bernardian. And that's where I'm basically going and doing this. So I kind of tend to stream only a couple hours a night, do it on Tuesdays and Thursdays from 7 p.m. Central to 9 p.m. Central time. During the day, I've got business stuff I got to do. Otherwise, I'd do it then. But I tend to do this at night. So that's what I've got for our community stand-up for this week. So our hope is to get Akka.net 1.421 released. So that way everyone can go ahead and get access to those performance benefits. And then we're also hoping to get some more feedback on how things have gone with the beta so far. So in case there's issues with the dependency injection setup or anything else, we want to make sure all of that is in absolutely top-notch shape for our users. So thank you very much for your time today. If you have any questions, you can go ahead and leave it on the discussion thread. Otherwise, we'll plan on seeing you in a month. Gregorius, do you have anything you want to add before we sign off? All right. What'd you think of that little draw together sample? Oh God, yeah. The UI is definitely not my forte there. I would welcome someone's help if you wanted to help me add a Paint.net style color picker and a brush selection menu. That would be very much in your debt. Since I'm kind of winging it at the moment on that stuff. But yes, the actual server-side sync technology is pretty cool. Oh yeah, that reminds me, the one last thing I'm working on. In fact, I've got a pull request I need to go ahead and open up for it right now. I'm going to go ahead and put this in a draft. Add Blazor startup compat. Go ahead and draft this. One of the things that we're going to work on, and I don't know how far we can get with this realistically, but one of the things I'm trying to work on, I discovered under the stream last night, is there's some features that we're calling inside Blazor that are totally not supported. Sorry, there's some features we're calling in Akka.net that are not supported in WebAssembly, and they're pretty trivial things for the most part, such as changing the color of the console. That's a platform setting that's not available. So there's a way I can go ahead and detect some of that stuff when Akka.net starts. There's an attribute that Microsoft uses that signals that this method is basically not supported on this platform. It's a little attribute we can look at. I'm going to try to do that and try to turn the colored console off on platforms so it doesn't work, because I want to try to get Blazor actually running inside WebAssembly itself. Running Akka.net on the server that Blazor uses, totally supported. But running it actually inside the client, not so much. So thank you very much for your time today, everybody. I really appreciate it. And we'll look forward to catching you at the next one of these in about a month. Take care.